Hello physicists and welcome. In this session we'll look at accelerated motion based off a claim and evidence. We're going to support our claim with evidence from motion maps or from graphs. Let's get started. In this first problem, a cross-country runner is running at even time intervals during the first few steps of her race. Make a claim about her motion and provide evidence to support that claim. And we can see that our runner's position is here, then here, then here, then here. Hey, so we can see that these positions in subsequent seconds are getting further apart. So my claim is going to be, my claim here, the runner is running with a positive velocity with positive acceleration. We could probably also say a positive velocity with increasing velocity as well. Hey, first I'm going to make, let's see, some evidence with a motion map, and I can end up putting dots pretty much lined up with where they are above. That's position 1, 2, 3, 4. Let me go ahead and draw on those arrows. Hey, a motion map provides the direction with the way the arrow faces and the length of the arrow to indicate what the velocity is. So the evidence I have to support this statement is first that the arrows point to the right, so that supports the first part. The runner is moving with a positive velocity, and the second one is with positive acceleration. So the second part of the statement is, and the arrows are getting longer, showing an increase in velocity, which we call acceleration. And the next piece of evidence I want to do is with a position graph. Position graph has position, and right now we don't know what the units are, but there'll be some arbitrary length unit over time, and we'll assume this is in seconds. So I've made a little grid here. I'll assume that the runner is at a position of 0 at a time of 0, moves a little bit forward after 1 second, moves further ahead after 2 seconds, moves even further ahead after 3 seconds. We can see that we don't have a linear shape, but we have a curve. We have an upward curve. And so my statement here is that the position versus time graph is curved upward. First, that we end up having a positive slope that tells us we're moving in the positive direction, and it's getting more and more positive. It's curved upward, so that supports both that it has positive velocity with positive acceleration. Hey, last item I want to support this with is with a velocity graph. So on a velocity graph, we'll have velocity on the vertical axis, time on the horizontal axis. We'll arbitrarily assume that these are seconds on the horizontal axis and meters per second on the vertical axis. We can see that as the arrows are getting longer, that we end up having starting at some initial velocity at a time of 0. That increases after some time, gets longer and longer. If we take a look at this, we see that our velocity is always positive and increasing. So we see both that the runner has a positive velocity, that's in the positive side of 0, and is increasing, which we call positive acceleration. The next example is found on the bottom of page 16. And we see a velocity versus time graph. That's important that we see first what type of a graph it is, velocity versus time. And here's 0, so these are all positive velocities. Hey, and so our claim is the object moves a distance of positive 30 meters in 15 seconds time. Let's first support the first part of this. The object moves a distance of positive 30 meters. Let's see if we can prove that it's positive. Hey, and I see this, that the entire time the velocity is always positive, so our displacement must also be positive. So I'll put that in my evidence statement. So I put it in this statement here, at all times the velocity is positive, so the displacement is positive. It's easy to look at this type of a graph and think that, hey, something is going down, and if you assume that that is position, you'd say, hey, it has a negative velocity. That's why it's really important to look at what the velocity means and where the axes are. These are always, it's always positive. It may be going fast and slowing down, but it is always positive. Hey, so let's take a look at the next part. Okay, 30 meters in 15 seconds time. Well, the 15 seconds is going to be pretty easy to show because we go from 0 to 15, let's see, 0 to 15 seconds. That's going to be pretty easy to show. The next part is our 30 meters. All right, let's take a look at what, how we can prove that. Hey, the first part of this is that the area of a velocity versus time graph equals the displacement of an object. You see that here. Hey, the area of a velocity versus time graph equals the displacement. Now let's go ahead and we'll have to calculate this. Hey, this area here looks kind of like a triangle with a height of, let's see, area of a triangle is equal to 1/2 base times height. Let's put in our numbers here. So we'll say it's 1/2 the base. 15 seconds. We prove that statement here. And our height in this case is times 4 meters per second. 15 times 4 times 1/2 is equal to 30 meters. It's above the x-axis, so the area between the x-axis and this line, or if we want to be fancy, the area under the curve is a positive 30 meters. And here I have it. The area is equal to positive 30 meters. You can use similar reasoning to complete the other claim and evidence statements for page 15 and 16.